Hello, we are Team One, and this is our project presentation on the Delivery Defender. So the problem that we were trying to solve was that the rise of online shopping means that there's a bunch of unattended packages on people's doorsteps. This leads to theft, which can be really frustrating for the customers because now they've lost money and it's really inconvenient to try and get it replaced. There's dissatisfaction with the lack of reliable and secure solutions to protect packages that are outside of homes and buildings, especially when they're vulnerable to thieves. So there's a couple of comparable products. For example, the Package Vault anti-theft solution. Um, this is locked storage. It's weather resistant and it's aesthetic, but unfortunately, it's limited to physical dimensions, and it does not accommodate for larger packages. There's also the Package Guard. This has the features of Wi-Fi enabled real-time alerts, and it has a loud alarm if there is a theft, but the size may limit placement options and it is reliant on batteries. There's also Amazon lockers, which allow people to get their packages sent to the lockers instead of their homes. So these are secure and they have app integration. But unfortunately, it only works for Amazon specific packages and it requires the user to travel to the locker locations. There's also video doorbell systems. These include motion detection, real-time alerts, and video recording, but it is mostly a deterrent, so it doesn't necessarily physically secure the packages, it just discourages people from stealing them. There's also the Box Lock Start Smart Padlock. This works with major delivery service and it has barcode scanning, but it requires additional storage container and it relies on delivery personnel for operation. Our project goal was to develop a general solution that reduces the likelihood of package theft and ensures that packages remain safe until the recipient retrieves them. Our objectives were to improve the security of delivered packages that are left unattended. We also wanted it to be easy to use for both the recipients and delivery personnel. We wanted it to be compact, inexpensive, and to operate reliably, no matter what the environmental conditions are, whether it's raining, snowing, or there's a heat wave. Um, and we also want it to remain functional even after somebody attempts to tamper with it. It should be easily installable and it should operate while being aesthetically pleasing. The way that we were going to measure these was to measure the security. We were going to monitor the number of package thefts per month. To see how easy it is, we were going to send out a survey to tell how compact. We measure the volume. To see how expensive it is, we measure the cost. To see how well it operates under various environmental conditions. We want to measure the failure rate across conditions as a percentage. Um, we have to determine if it's operable after tampering attempts. And then to see how easy it is to install, we will measure the time that it takes to install it. And then we'll have a survey rating in order to see the aesthetics as well. Um,
To ensure that our solution is practical and reliable, we established a set of constraints for the delivery defender. The system won't take up more than 5 square feet, so it fits on most doorsteps and does not obstruct delivery operations, ensuring it's easy to use for delivery personnel. It will run on battery, so it doesn't need to be plugged in. We'll make it big enough for most package sizes, but keep the cost under $600. We plan to finish building the prototype by April 1st. It will also work with drones, which are being used more for deliveries, and it will be strong enough to hold 300 pounds, so it won't tip over or break. And here we can see the table of the constraints along with its limits and requirements, as I had previously stated. Now that we've explained the design and constraints of the delivery defender, let's talk about how we plan to test it. We will test how well the delivery defender keeps the packages safe. First, we'll do 2 trials over a month, one with the delivery defender and one without it. This will show us how much it reduces theft. Then we'll try to break into it 20 times using tools and different amounts of force. If it stops theft, theft in at least 95% of this test, we'll know it's strong and secure. Next, we will test how well the system works in different weather. We'll put it in extreme heat, cold, and rain to see if it can still work. Our goal is for it to keep working 9 out of 10 times during each of these tests. We will also test if the delivery defender is easy to use. 15 people will be trying it. 10 will be the recipients and 5 will be delivery workers. They'll time how long it takes to use the system, and we want to average time to be less than 30 seconds. After that, they'll rate how easy it is to use and how nice it looks. We hope to get a score of 4 out of 5 or better. And we'll also test it with 20 packages of different sizes to make sure it works for most deliveries. And finally, we will test how easy it is to set up and if it works with drones. We'll try installing it on different surfaces like concrete and wood. Next, I will be explaining the list of concepts we initially created as a group for the delivery defender. The first concept consists of a one-way turnstile that allows packages to be dropped off but not retrieved without a key or code. Concept 2 consists of the key features of this design include secure floor anchoring with Atlas clamps, keypad access for controlled entry, and a platform with a pressure activated mechanism for drone deliveries. Concept 3 consists of a trapdoor drop box that can only open one way, and it looks from the outside like a table with weight sensor at bottom that will alarm if packages are removed. Concept 4, its features of this design is the simple package theft protection system with a separate drone delivery drop-off mechanism. Concept 5, design has an open lid mechanism in which the package will be dropped off, as well as having a slide for packages to drop to the bottom. Concept 6 has a style for reverse vending machine, which takes packages and stores them at the top in order to organize and keep the packages safe.
For the first concept, it is a simple delivery allowing easy drop-offs with minimal effort required for drones or delivery personnel. It protects packages from outside elements such as rain, wind, or any other element. The only cons with this concept is that light packages may not apply with enough pressure to push the tensile bars, and the tensile bars may experience some mechanical issues leading to potential delays during package drop-off. For concept 2, this is a 3 by 3 by 4, which makes it easy to put in various places. It is a securely anchored using access clamps, providing stability without need of any drilling or permanent modifications to access the packages. You just need a keypad, and there's a weight sensor on the top for drone pack delivery. The cons is that it requires an access code, which could lead to potential security concerns if not managed properly, and it may rely on consistent pressure on the play functionality for accurate detection for drone deliveries. Concept 3 is a gravity-based door that allows drones to seamlessly make deliveries. Uh, it is convenient for drop-off and encourages and prevents packaging from being theft from being left next to the device. Cons is that the swinging doors take up unnecessary space, limiting the size of the packages as that the packages may be too light to drop off through the spring-loaded doors. Concept 4, as you can see, is a simple theft protection system similar to the package drop-off. It is easy to install and dual protection for drone delivery with a motor latch, which utilizes a light sensor to detect the drone. The con is that it needs to be larger than 5 square feet, and the design has separate compartment for both drop-off systems. Concept 5 is a system that will open up as if it was a lid to be able to drop off packages, which will automatically open and close. The cons with this is that if the packages are too big, it can take up unnecessary space, as well as that small packages can be damaged during the drop-off process. And we can see from the video, concept 6 is a more organized concept. It is completely automated and it will secure the packages. The concept with this concept though is that it's limited by the number of plates that are loaded. It is a complicated design which would be more difficult to fabricate and is inefficient if all packages are considerably smaller than other plates.
On this slide, it demonstrates our final concept. Within our final concept, the device will open automatically with motion sensors. It will be a two-layer system, whereas once the top layer is closed, the second layer will open, dropping the package into a secure compartment, and then the second layer will close once the top is open, and then recipients can gain access to packages via keypad. And here it demonstrates the second layer. And the second layer, it will show that the garage panel will slide into a secondary compartment, keeping it out of the way. And then in that same compartment, it will also house the electrical components. And then we will also be putting holes in the bottom of our unit so that you can mount it in your property. On this slide, it demonstrates our mathematical analysis for our shaft. We're able, with these mathematical analysis, to find out the specifications for them. Here it also shows the equations, the calculations, and the strength that this shaft can take. On this, it shows the bearing mathematical analysis. It also shows the specifications that we came to. And then it also demonstrates your equations that we use, the calculations that was done, and then the strength of the bearings. On here, it shows a numerical analysis. We started with the exoskeleton for our frame, and then we started with a 300-pound force to represent human force. And then we also decided to test more possible tampering. And so we went to a sledgehammer that was 1,250-pound force, and we simulated that. And then as you can see by the load multipliers, the frame did not buckle or break under these conditions. On this, it shows that the sledgehammer force on the panels, and same thing as you can see with the load multipliers, it does not bend or buckle or break, ensuring that it's durable and will keep the design secure.
We then looked at the shorter top panels for under the sledgehammer force. The same 1,250-pound force was applied, and we can see by the load multipliers on both the top panel and the side panel that it would not buckle under these forces. We also applied prying forces at different locations on the top and both side panels to see if it would deform too significantly. And we can see that the max deformation was under an appropriate amount. We compiled a list of these components that we spec'd out. We're going to use a 1/4-inch diameter aluminum rod for the axle, appropriate size bearings, and 1-inch square galvanized steel tubing, which has the appropriate properties that we tested. For our concept demonstration, we constructed a steel frame made of tubing. So here's the layout plan for the components, or for the stock components that needed to be cut. 3 different lengths with different hole mounting patterns. In order to construct it, I first marked everything with Dykem blue layout fluid and used a scribe to mark the measured locations. I remeasured those, then cut them on a bandsaw. And then for the 45-degree angles, I cut them on a vertical bandsaw and then used a grinding stone to grind it down to a precise angle. Once this was done, I took all the pieces and used a manual mill in order to zero and then measure and drill in the appropriate locations. I drilled 1/4-inch holes for the through holes that will be used to mount the aluminum cross brackets, and 5/16 holes that can accommodate welding nuts later for bottom panel mounting, side panel mounting, and then top door mounting. I needed to then sand off the zinc coating because the galvanized steel coating can vaporize when welded, creating toxic fumes. So used a pneumatic Dremel in order to take that off. And then tack welded the top and bottom rectangles of the frame together. The rest of the process would be to complete welding the seams and then angle grind them down to make them look nice.
There was a few challenges when developing this prototype. One of them included the stock length. When the parts were delivered, it came in certain sizes that made it impossible to get the exact lengths that we needed for each of the steel tubing. So what we were required to do is to seam and rejoin the two parts to get the correct stock length. We also had limited shop access due to the fact that there were a lot of other capstone classes that were using the machine shop and a certain amount of training that needed to be done with the limited time frame that we had. We also had the problem of using galvanized steel. Galvanized steel is a very hard material, which made it difficult to machine and fabricate in certain ways. There was also the zinc coating that was on it, which makes it toxic when welding or when it reaches a certain temperature. So we had to sand that off in order to weld it correctly. And also the difficulty of the welding boot space. This space was smaller than our product itself, which required some finesse in order to accurately weld it within the confined space. So in figure 30, we can see this is the complete frame. It sits flat on the ground. The edges are all tack welded, so it is required to be fully welded later on, and would need to angle grind down to smooth it all out and make all of our final adjustments. Some of the features that are included and will be added start with the 1/4 through holes for adjustment of the top compartment size, which can be seen in figure 32 with the 6 holes on the side, which allow for the L-shaped bracket to move up and down, changing that top compartment size. There is also the 5/16" holes for the weld nuts, which will allow for certain panels and the outer layer to be attached. And then there's the mounting holes for the side and bottom panels. And then this will all allow it to be sturdy and stable. So for our budget, we used $148.14. This is much lower than the amount we still have left, which is $451.86. Although we still have to buy the sliding panels, the motors, the motor controller, which could be an Arduino, battery, and sliding garage doors or rails, and brackets. So, in conclusion, the Delivery Defender project addressed secure package delivery challenges by developing a theft-resistant and drone-compatible system. We identified the need for a secure, user-friendly, and cost-effective solution, with goals and constraints guiding the design process. We evaluated multiple design concepts and finalized an innovative double-layer system to maximize security and functionality. We also conducted engineering analyses to verify structural integrity against potential impacts and prototyped key mechanisms, including the operation of the second level for opening and closing, as well as the functionality of the top section. Delivered a cost-efficient solution with a total material cost of $148.14 to construct the frame, ensuring a balance between affordability and performance. We lastly developed a comprehensive design process that combined concept evaluation, engineering analysis to ensure a functional, reliable, and user-centered solution. These are some of our references from the robust delivery storage, the Atlas mounts, the motor, the MasterCard, and the package garden, as well as some of the stock we used and some of the other comparable products.